Hi, I'm Oleksii, lead QA engineer at ORIL. Today, I'm excited to walk you through the nuts and bolts of API testing using REST Assure. It's a practical, hands-on guide that aims to equip you with the know-how to run your API test effectively. Ready to get started? Let's dive in. What is API testing? API testing is a type of software testing aimed at verifying the functionality and reliability of an application programming interface, through which different components of an application can communicate, allowing for data exchange and function sharing. What is REST Assure? REST Assure is a Java library used to verify the REST APIs. This library functions as a headless client to interact with RESTful web services. Let's explore the REST Assure framework with a practical example, using our Java demo project. Step 1. Choosing a test project. Let's begin by selecting a pet store test project and focusing on covering the four main roles: get, post, put, delete. Step 2. Configuring project. I created a simple project with Java 11 and mailing, then added the following dependencies to the POM.xml file. Unit 5 will be used for writing and executing our test cases. REST Assured, our main framework for API testing. JSON and Lombok. These libraries are used for serializing and deserializing JSON data. Data Faker provides an easier way to generate test data. Allure report will be used to generate detailed reports after running our tests. Step 3. Creating test classes. First, I created the best test class that set the base URL of the test service and enabled login requests and responses for easier debugging while developing tests. Next, I created the pet control class using REST Assured. This class had 4 routes of interaction with the pet store's API. This includes methods for creating, retrieving, updating, and deleting pet records. After that, I created the pet class using Lombok. This class represented pet data based on the fields defined within the Swagger specification. It serves as a data model for working with the pet information, making it easier to serialize and deserialize data when interacting with the API. Lastly, I created the pet steps class, which extended the pet control class. In this class, I implemented methods that call our HTTP endpoints, perform assertions on the response status code, and deserialized the response data into our pet model. This class played a crucial role in structuring our API test scenarios and ensuring that the API worked correctly. Step 4. Creating tests. I created the pet test class by extending it from the base test. The class consists of 3 positive tests that validate the API's expected behavior when everything works as intended, and 1 negative test to check how the API manages faulty requests or unforeseen situations. The first test case is focused on the create new pet functionality using the HTTP post method. In this test, I sent a request to the API to add a new pet to the system and ensure that the pet is created successfully with all expected attributes. First, I created a pet DTO that represents the pet data, including all the required fields. To generate realistic test data for this class, I have utilized the Faker library and followed the builder pattern. This enables us to effortlessly fill the pet DTO object with mock data for our test cases. Then, I sent a post request to the server to create a new pet. Then, I called the verify pet is created function to validate the response matches to the request. Finally, after the test, I called the delete pet function to remove the pet that was generated. The second test is focused on getting our pets by their status using the get method. I have defined a pet status enum that includes available, pending, and sold, and tested for all 3 cases. I created a test function that used the Unit 5 annotations enum source and parameterized test to parameterize the method with enum, providing 1 property pet status to the function. Next, I created 9 pets as preconditional step. Then, I sent a GET request to the server to retrieve the list of pets. Finally, I called the verify get all pets by status function to ensure that the response contains only pets with the selected pet status. Also, I created a fail test to demonstrate how broken test appears in the report. The test involves attempting to delete a non-existent pet. Step 5. Generating and managing test results with Allure report. Let's run all the tests and then manage the results. All the tests will be run in parallel mode using Unit 5. As mentioned previously, Allure was used for the report generation. Once the test run is complete, Allure generates an Allure record folder containing all the results. To view the results, simply run Allure surf in the terminal, which will start a local web server with the results. Let's select Create New Pet Test, which displays a step-by-step guide for the process with all requests and responses. Now, let's switch to our unsuccessful test of delete non-existing pet. The error message states that the expected status code was 200, but it returned 404, indicating that the pet was not found. This tutorial provided a hands-on journey through API testing using REST Assure, highlighting its easier and efficiency in validating API interactions. With REST Assure, maintaining a robust and reliable API ecosystem is now easier than ever. Thank you for watching. I hope you found this walkthrough useful for your API testing efforts. There's always more to learn, and I'm looking forward to sharing more practical insights in upcoming tutorials. Stay tuned for more, and feel free to dive back into any parts of this tutorial as needed. Happy testing!